Congruence transformations, lesson 4.7. A transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. A transformation can change the position, size, and shape of a figure. A congruence transformation, also called rigid transformations or isometry, is a transformation in which the position of the image may differ from the pre-image, but the two figures remain congruent. A translation is a transformation that slides all points in the plane in the same distance in the same direction. Example 1. Translate triangle ABC 5 units right and 4 units up. 1, 2, 3, 4, 5 units right. 1, 2, 3, 4 units up. A prime is right there. B 5 units to the right, 4 units up. B prime is right here. And ordered pair C, 5 units to the right, 1, 2, 3, 4, 5, 4 units up. C prime is right here. Notice the new ordered pairs are labeled as A prime, B prime, and C prime. And then I just go ahead and connect the points. So there is my new image. Now let's translate polygon ABCD 3 units right and 5 units down. One, two, three, 1, 2, 3, 4, 5. So A prime is actually going to be where the current ordered pair C is. B prime is going to be right here. C prime, 3 units to the right, 5 units down. And D prime. I'm going to go ahead and connect my points. So here's the new image. There's something interesting to see. The original or the pre-image, point A was the ordered pair -6, +6. A prime is the ordered pair -3, +1. B prime is the ordered pair 0, 1. C prime is the ordered pair 0, -4. And D prime is the ordered pair -3, -4. If I look at these points and try to compare the image with the pre-image, I see that there is a change in X of 3 units. I've added 3 units. So if I were to describe this translation, I would say that X has been moved 3 units to the right, and Y, if I compare my Y's, it went from 6 to 1, Y has been moved 5 units down. So this is how we describe a translation in terms of X and Y and an ordered pair. All right, let's describe this translation as a change in the X and Y coordinates. So I'm going to start with the ordered pair X, Y, and I'm going to see how I've translated it. So when I look at the pre-image, I see D is the ordered pair 1, 6. Let's see what the change in X is. The image for the ordered pair D prime is actually -1, -1. So the change in my X coordinates is actually a difference of -2. And that makes sense because I actually moved 2 units left. So when I describe the change in my X, I'm going to say X minus 2. Now let's take a look at our Y coordinate. The Y coordinate for the pre-image D was 6, and now it is -1. That's a difference of 7, Y minus 7. And that means that I went down 7 units. 1, 2, 3, 4, 5, 6, 7. And you'll notice that D has moved down 7 units. So this is how we describe a translation using ordered pairs. Let's take a look at this one more example, and we'll just do one ordered pair. Let's look at the ordered pair V. V is the ordered pair 3, -4. Let's look at V prime. V prime is the ordered pair -1, 3. So if I wanted to describe this translation in terms of an ordered pair, XY, I can say that XY is translated, let's see, the X coordinate is moved 4 units to the left, X minus 4, and the Y coordinate is moved, the difference between -4 and 3 is 7, 7 units positive, Y plus 7. So again, this is how we describe a translation in terms of an ordered pair, and all of those points would model this translation. A reflection is a transformation that flips a figure over a line. So I actually want to reflect triangle ABC over the x-axis. So the easiest way to do this is just to figure out how many units each point is away from the x-axis or whatever line you're reflecting it over. So point A is 1 unit away, so I'm going to go 1 unit in the opposite direction, label that A prime, B 1 unit in the opposite direction, B prime, and C is actually 6 units away, 5 units away, so this becomes my C prime. I'm going to connect my points. So this is triangle ABC reflected over the x-axis. All right, now let's go ahead and reflect triangle DEF over the y-axis. So again, same concept. F is 1 unit away, so I'm going to put point F 1 unit away on the other side, F prime. D is 6 units away from the y-axis, D prime 6 units away, and E is 7 units away, E prime. And then I'm going to go ahead and connect my points. So there's a special rule when we reflect over the x-axis. So when we reflect over the x-axis, the x-coordinate for the reflection, see this represents some kind of transformation. The x-coordinate stays the same and the y-coordinate is the opposite of what it was originally. So this is when we reflect over the x-axis. When we reflect over the y-axis, again, this is representing some type of transformation. The x-coordinate becomes the opposite. So this is the pre-image, this is the image. So whatever the x-coordinate was in the pre-image, it will be opposite in the image, but the y-coordinates stay the same. So that's a cute little rule, helpful. So a rotation is a transformation in which every point moves along a circular path around a fixed point. We generally do counterclockwise rotations in increments of 90 degrees with a center at the origin. So if I were to look at this drawing, I see that I have the pre-image triangle A, B, C. And I can see that when I rotate triangle ABC 90 degrees, I'm actually moving point A 90 degrees to A prime. I'm actually moving point B 90 degrees to B prime. And I'm actually moving point C 90 degrees to C prime around the origin. So let's look at how we kind of perform this operation, and then we'll go over some tricks. All right, so here I have triangle ABC, and we want to move it clockwise 90 degrees. So I see that the ordered pair for the pre-image A is the ordered pair 1, 4. Now I need to move this point 90 degrees. And so what I'm going to do is actually change it so that my image is going to be at -4, 1. I kind of change the order and make it opposite. So when I go to the image, I'm going to put a point at -4, 1. And this is where A prime is going to lie. Let's do the same thing for B. So B is the ordered pair 5, 6. So B prime is going to be the ordered pair -6, 5. -6, 1, 2, 3, 4, 5. This is where B prime will live. And C prime is the ordered pair 4, 0. Sorry, C is the ordered pair. C is the ordered pair 4, 0. So C prime is actually going to be the ordered pair 0, 4. 0, 1, 2, 3, 4. So you'll see that each one of these have been rotated 90 degrees. I'm going to go ahead and connect the points so you can see that triangle ABC has been rotated 90 degrees about the origin. So the tricks for this one is, again, if you have a 90-degree rotation, the y-coordinate of the image, the y-coordinate of the pre-image becomes the x-coordinate, and I use the opposite of it. So you just kind of have to look at these and see what's going on. Practice it a couple of times. You know, I don't think that you need to commit these to memory as long as you look at them while you're working on your homework. Kind of see what's going on and make it work for you. So that's it. Your homework is actually a worksheet. I think there are 12 questions, maybe 15 questions on there, and that will be due Monday in class. Thanks so much.